Hello, grade 11s and grade 12s. Guys, I found a very interesting way of sketching trigonometric graphs. And the method that I'm going to bring to you, if you use this method, you will never go wrong in your sketching of the graph. You'll never go wrong. Okay, I'm going to start with the simplest function first because there is something that I want to show you. So I'm starting with this f of x equals to sine x. I know they will never ask you in the exam to sketch this one. Let me say never, but let me say it's very rare. Let me say they will never. Let me say it's very rare that they will ask you to sketch this graph of sine x, this simplest graph. I'm starting with it because there is something I want to bring to your attention. Please, guys, what you are going to do when you sketch the graph, actually, we will tell you the starting point. Let me say I want it to start at negative 360, and we will also tell you the ending point, 360. So let's start. We are going to rely on a calculator. It's going to be the best method for sketching the graph. So what we do, we press mode. What's happening? Am I not pressing mode? I don't know if my calculator has changed or what. Let me just cancel and start it over. Mode. Yes. So you press mode on your calculator, then you press free for a table, then you insert the function. You say sine, you say alphabet x. You close, you say equals to. Now the calculator is asking you, where do you start? I said to you guys, start this graph at negative 360. So you're going to start at negative 360. You're going to press negative 360. You say equals to. Where do you end? I said let the graph end at 360. I said let the graph end at 360. So I will say 360 and say equals to. Now the key point, this is the key point. If you get this one right, you will always get your functions trig graphs right. Put the step of 15. I advise you to always put the step of 15. I know why. Actually, I'm choosing the step of 15. You will never go wrong when you sketch the graph. Always pick 15. So now here, you pick 15. You say equals to. The calculator say insufficient memory. So the calculator says you are asking too much. You are asking information from negative 360 to 360. Remember, I said let the graph start at negative 360 and end at 360. So we are asking information from negative 360 to 360, and we are using such a small step, which is the step of 15. So the calculator says insufficient memory. But if you use a different step here, let me say, let's go back to the sketching of the graph. Let's press mode and okay, let me say we are starting. Let's press mode and we press free for table, and then we press sine alphabet x. Where do we start? I said we start at negative 360. Where do we end? We end at 360. If we change the step, if we say the step is 90, the calculator will be able to provide us with information. If we say the step is 90, the calculator will be able to provide with information. But guys, I really want us to focus on the step of 15. Let's not go to the step of 90. So what do we do? Let me show you again. If you if you say mode free, you say sine alphabet x. If you say I'm starting at negative 360, oh, sorry. If you start at negative 360, if you still say you want to end at 360, the calculator will not give you information if you are using the step of 15. Let me do it again. If you end at 360 and you are using the step of 15, calculator will say insufficient memory. So what are we going to do now? I'm going to show you what you must do. Something interesting that I want us to do, something interesting. You're going to say sine alphabet x. You start at negative 360. Even though we are saying your graph should end at 360, for now, please end at negative 180. So you're going to have something like this. Remember, we want you to sketch the graph from negative 360 and end where? At 360. But you, for now, you say, okay, I'm starting at negative 360. I'm ending somewhere here at negative 180. So the calculator will be able to give you the information for this first part from negative 360 to negative 180. So let me end at negative 180 for now. Let me say we end at negative 180. Step, I still want the step of 15 is going to be our key step. Always use the step of 15. Guys, I know why I'm saying this. There are certain graphs which when you sketch them, you will really need to use the step of 15. So let's always use the step of 15. Now, you see, the calculator is now able to give you the information from negative 360, where x is negative 360, to where x is negative 180. So it gave you too much information, and some of the information actually you don't need it. So which information do we need actually from this table? Please, please, please. When you sketch the graph, you always need your intercept. You need things such as the x-intercept. So you need the x-intercepts. The x-intercepts, we are referring to the values of x where y is 0. So if you look on the calculator, when x is negative 360, f of x is 0. We really need that point because it's the intercepts. We must show it on the graph. So I'm going to say negative 360 and 0, I need you. You are the x-intercept. Now I'm going to put this dot on my graph, negative 360 and 0. Now I go back to the calculator and I ask myself, do I need this negative 345 and 0,2588? No, I don't need this one. Negative 330 and 0,5, we don't need it that much. I know why I'm saying we don't need it, but the way it is, we can use it for now. We can say negative 330 and 0,5 because it's so neat. The y value, it's so neat. It's just 0,5. It's a half of 1. So let us show it on the plane, Cartesian plane. So negative 330, negative 360, maybe negative 330, it's somewhere here, and 0,5 somewhere here, 0,5. It seems like for now I am complicating the sketching of a graph, but you are going to see the importance of what I am doing now when we sketch complicated graph. The method that I'm using will make the complicated graph to become simple. So negative 330 and 0,5. Negative 31 and 0,70, I don't really need it. Negative 300 and 0,866, I don't really need it. Negative 285 and 0,9659, I don't really need it. Negative 270 and 1, as kids, I need it. I must show it on my graph, negative 270 and 1. Why? Because it's the turning point of my graph. Negative 270 and 1, we need it, is the turning point of the graph. How do I know that this negative 270 and 1 is the turning point? If you look at this graph of sine x, this graph of sine x here, the value before the trig ratio, the number before your trig ratio, it's 1. And this one, it's actually the amplitude. It represents the amplitude of this graph of sine x. So it is the highest value of y. So that we know that the graph actually tends at the value where y is 1. So negative 270, I must show it. Let me say, suppose it's here. So I'm going to say negative 270 and this one. So we put a dot here. Now, let me go down. I don't need this one. 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 Negative 210 and 0.5, you might show it, but you don't actually need it. Negative 195, negative 180 and 0. This is the x-intercept. Negative 180 and 0 is the x-intercept. Let me write it down. I need it. How do I know that is the x-intercept? The y value is 0. So now I'm going to show it. It's here. So now, boom, I'm no longer having information because I said, give me the information from negative 360 to negative 180. So what I'm going to do now, I'm going to start again. Sorry, let me say, let me say. Okay, I'm going to start again. I'm going to say mode 3 and then insert my function again. Sine alphabet x. Where do I start? Now I'm going to start at negative 180. I'm going to start here. I need information from negative 180 now to where? To 0. So I'm going to start at negative 180. Where do I end? At 0. What is my step? Always use the step of 15. This is our key idea. This is something important that you must, please, guys, use the step of 15. You will not go wrong when you sketch any graph. Any trig graph can be simply sketched when we use the step of 15. Now, let's look at the information, negative 180 and 0. Now, some information, you actually don't need them. So, negative 90 and negative 1, we need it. Negative 90 and negative 1, we do need it. So we're going to say negative 90 with negative 1 is this point. Okay? Why do we need this negative 90 and negative 1? After all, if you look at these coordinates, they are so neat. They are not even in a decimal form. You look at the value of y is negative 1. Unlike this other's values is negative 0.965 here, negative 0.866 here, but negative 90 and negative 1. The value of y, it's so neat. It's not in a decimal form, but is the main reason I'm actually using negative 90 and negative 1. I know that the graph, when it comes underneath, let me show you here, the graph will go like this, 10 here, and then negative 360, 10 at negative 270 and 1, go here, negative 180, and then the graph will here minus 90 and minus 1. Oh, minus 90 actually it's here, sorry. It's here. Minus 90 and minus 1, it's here as keys. How can I even, the x cannot be negative this side. I'm rushing. Yes, my x is minus 90 and negative 1. It's here. So when the graph comes underneath, it will turn at this negative 1. So that is why it's important to show the turning point. Now, let's go back to the calculator. Minus 75 and minus 0,965, we don't really need it. Minus 60 minus 0,866, we don't need it. Minus 45 minus 0,707, we don't need it. Minus 30 and minus 0,5, you might show it. Minus 15, 0 and 0, we need it. That is the x-intercept, and it's also the y-intercept. So you put it here. Your graph will be like this. Okay, so now you can continue again. Now you say, I need information from 0. You now say, I need information from 0 maybe to 180. So you are asking the cashier to give you information in pieces, because it says I cannot give you information once, but you ask it to give it information in pieces. Now you are going to say, you start again with a table. You say sine alphabet x. You say start at 0. You say end at 180. You say step of 15. It gives you information, but some of the information you don't actually need it. 90 and 1, I will need it. 90 and 1, because this is where the graph turns. It turns here. 180 and, okay, let me check what other information is there. You don't need it. You go for 180 and 0. 180 and 0, it's here. You will have 270 and negative 1, 360 and 0. So your graph goes like this. And then it was going to be simpler here if you used the step of 90, but please don't use the step of 90. I have a valid reason, guys, in the future. Please, please, please. Okay? Because finding the correct step is what matters when we draw this trigonometric function. Now let me bring bit complex graph. Let's say they want us to sketch the graph of cos. Let's call it g of x. They want us to sketch the graph of cos 3x minus 45. This graph, 3x minus 45. Let me erase everything. This is where now you will see the importance of using my step of 45. Okay, so y exists, x exists. Now let's say we want you to sketch the graph between, negative 45 and 135. Negative 45 and 135. So you know where you must start. I'm going to start at negative 45. Okay, now let me use my calculator to sketch. Let me say mode and then press free for the table and then insert my function, which is cos 3 alphabet x minus 45 close the bracket. Okay, let me do this. Maybe this is a hiding. Yes, 3x minus 45. Then you say equals to, where do we start? Negative 45. Where do we end? 135. What is our step? 15. Always use the step of 15. 15. Yes. Wow. You now have all the information actually from negative 45 to 135. Now you start sketching. You say negative 45 and negative 1. Negative 45 matches with negative 1. It's your first point. Negative 30 with negative 0.707. Okay, you can see that on the other graph, when I was sketching sine x, some information I was cutting out. Okay, some information you actually don't need it. Okay, but the more information you provide, the better. The more information you provide on your graph, the better. So here, I'm going to put everything actually that I see on my calculator. I'm going to say minus 30 and minus 0.707. Maybe somewhere here. This is minus 0.707 here. Okay, now I'm going for minus 15 and 0. This one is important. You must show it on the graph because this is your x-intercept. Why am I saying is the x-intercept? Look at the value of y, it's 0. So the x-intercept must be shown on the graph. This is a very, very important point. So this minus 15, it's very important that you show it is the x-intercept. And then 0 and 0.70, it's very important that you show it. Why? Because it's the y-intercept. When you see is the y-intercept because we see that the value of x is 0. It's 0 and 0.701, guys. This point is important. So on the graph, if 1 is here, 0.707, you show it on the graph. It's your y-intercept. It's very important that you present it. And then 15 and 1, we must show this 15 and 1. Actually, I will explain why again this 15 and 1, it's important. You must 15 and 1. So 15 and 1. This 15 and 1, guys, it's very, very, very important. Why? Okay, listen, pay attention. If we come to this graph of cos 3x minus 45, this function here, the number before my trig ratio cos, the number here before, it's invisible one, which means that the amplitude of this function is 1. The highest value of y is going to be 1. The amplitude of this function is 1. So that it's the turning point. So this 15 and 1, it's very, very important. It's where the graph turns. Okay, then 30 and 0.7071. Let's show it. 30 and what? 0.7071. It's here. And then what? 45 and 0. 45 and 0. It's a very important point because it's the x-intercept. It is x is 45, y is 0. It's a very important point. 60 and negative 0.70. This point, even if you did not show it on the graph, this one, 60 is here, and negative 0.70, even if you did not show it, it's not a big deal. Okay, and then 75 and -1. It's a very important point. You must show it. 75 and -1. I will explain why this is so important. 75 and -1. This one, it's here. Okay. 90 and -0.7. Let's just show it. I don't think it's that important. This point, it's here. Okay. 105 and 0, it's important, is the x-intercept. It must be shown on the graph. 105 and 0. 105, 105 and 0, it's here. And then 120 and 0.701, 135 and 1. 135, 135 and 1. So the graph goes like this. Sorry. The graph goes like, excuse guys, let me try to make it neat. The graph goes like this. It goes like this. It's 10 here. It goes like this. It goes like this. It turns here. It goes like this. So show the critical points. Let me show the critical points. -15 and 0 is the x-intercept. You must show it neatly. This point, it's 0 and 0.707 is the y-intercept. Please show the x-intercepts and the y-intercept must be shown. This one is the turning point. Show it. It's 15 and 1. This point is the x-intercept. Show it. 45 and 0. This is 75 and -1 is the turning point. Show it. This is the x-intercept. It's 105 and 0. You must show it. Yes, so this is the graph of g of x. Look at how neat it is. When we use the step of 15, we will never go wrong. This is my key concept. When we use the step of 15, we will never go wrong. Let me sketch another graph, which is sine 2. Let me show you another function that I want us to sketch. You will never go wrong, guys. If you use the step of 15, you will never go wrong. It's sine 2 into x plus 45. Let's say is g of x equals to. And they want you to sketch it still from -45 to 135. Okay, let's start mode. Free for table, then we insert the function. We say 2, sine, we say sine, and then we say, okay, 2 into, okay, let me say sine. I'm facing a challenge here, guys, because you have to say 2 into x plus 45. But let me explain this. This sine into 2 into x plus 45 is the same as 2x, which is 2 times x is 2x, is the same as 2x, 2 times 2, 2 times 45 is 90. This is the same as 2x plus 90. So you can say on your graph, you can say 2 alphabet x plus 90. How did I arrive to 2x plus 90? I used distributive law. I set the number outside the bracket. This 2 multiply x is 2x. This 2 multiplies 45, it's 90. So it's sine 2x plus 90. Then you say equals to. Where do we start? We still start at minus 45. And where do we end? 135. Well, what is your step? Step always 15. Boom. We have all the information we need to sketch the graph. Now, let me say my y-axis and my x-axis. Okay, now watch out. Negative 45 and 0, I really need it. This is my x-intercept. How do I know that is my x-intercept? Because the y value is 0. My minus 45 and 0 simply means that x is minus 45 and y is 0 is the x-intercept. So I have to show this point very well on the graph. Actually, the intercepts, you must show them. This is minus 45 and 0. Now, minus 30 and 0, 5. I'm going to show this one, minus 30 and 0, 5. Minus 30, it's here. So this point here is 0, 5. Here it's 0, 5. 30 and 0, 5. This point, even if you did not show it, this minus 30 and 0, 5, I don't think it matters because it is not the intercept and it's also not the turning point. Okay, so now we have minus 15 and 0, 866. I might also not show this one, minus 15 and 0, 866, but just for you to follow, let me just show it. Minus 15 and 0, 866, which is a number closer to 1. 0, 866. This is 0, 86. It's a number closer to 1. Another one is 0 and 1. 0 and 1, it's a very important point. It is the y-intercept. We really need to show it on our graph. So let me say my 1 is here. So I need to put a point here. You can even show that this is 0 and 1. It's a very important point, is the y-intercept. I wonder where the graph turns because the turning points are also important, need to be shown on the graph. 15 and 0, 866. 15, obviously it's here, and 0, 866, somewhere here, which means actually the graph might have turned at 0 and 1. Can I say the graph turned at 0 and 1? Yes, yes, because this function sine 2 into x plus 45, if we look at the coefficient of the trig ratio sign, the number before sign, it's invisible 1. So its amplitude, it's 1. It's the highest value of y, it's going to be 1. So yes, this 0 and 1 is our turning point. Okay, okay. Now I'm going to 30 and 0, 5. Let me show it. 30 and 0, 5. It's here. Let me show it. 45 and 0. It's another important point. 45 and 0. This is the x-intercept. It's here. Okay. 60 and negative 0, 5. 60 and negative 0, 5. It's here. Let me say minus 0, 5. 75 and negative 0, 866. 75, and negative 0,866, it's here. Negative 0,8, let me put it here. 90 and negative 1, 90 and negative 1, 90 and negative 1, it's here. Let's say here we have negative 1. So this is 90 and negative 1. And then we have 105 and negative 0,866. You will show it. We have 120 and negative 0,5. Okay, 120 and negative 0,5, it's here. 135 and 0, it's a very important point, is the x-intercept. It must be shown. It's here. And then your graph goes like this. Turns here. Come back. Turns here. And then go here. Then you show the critical point. You show that minus 45 and 0 is the intercept. We show it. 0 and 1 show it is the turning point and also the y-intercept. 45 and 0 show. 90 and negative 1, please show. 135 and 0, please show. And name your graph. This is what? G of x. So guys, if you use, please, if you use the step of 15, you will never go wrong when you sketch the graph. Trigonometric functions, I think, done deal, dusted. You are no longer going to struggle with the sketching of this graph. Thank you so much. See you next time and God bless you.